Hey.
It's going.
All right.
Oh, ça résonne avec le feu.
Ouais, c'est génial.
Tu vois, j'ai fait des petites étiquettes. Ah, je sais pas qui. Et donc voilà, je peux sortir ça un moment.
Ce qui est drôle, c'est que mon article dans le sort là.
C'est vrai?
Ça s'ouvre tout de suite.
À 13, faut que tu le dises. Faut que tu le dises.
Mais pour l'instant, il dit pas.
Si tu le dis pas, je le fais. It has an article that just
That will
came out on Nature today.
Oh, really?
Yeah.
It's supposed to appear at 1 p.m. East Coast time, and it's 8 p.m. and it's still not there. Maybe they're lying to me. They're lying to me.
It's not April 1st though.
Yeah, maybe I received the email April 1st.
It's not
Let me
nature.
check. It might have been a joke.
It's not nature physics, it's mature physics.
Yes.
What's the title of the article?
Well, it's called Fractional Quantum Excitations in the Heisenberg Spin Chain.
Somebody subtitles for that too.
Subtitle. I may have a chance to explain about it today.
Yeah, no, that.
My name is Marcus Sivan, and I'm representing the Institute of Contemporary Art Baltimore today. Lou Joseph is the director of ICA, but it's a group of advisors, which includes myself and some other people. And the institution floats around, so we've had shows in different places. And the idea is that they're solo shows by artists. We have a walkthrough of this exhibit today. This is a great crowd. I remind you, if you haven't already, call your father. It's fine. If you have a father, call your father. He'd appreciate it. Instead of doing a lengthy introduction, since this is a casual affair, I thought, and sometimes those introductions can just be ridiculous. And you guys can all Google. We have an artist and a scientist here today, which I think is a unique afternoon. And I think we'll start by asking our scientist to introduce himself and to tell us what he does. So for us who, many of us, I'm looking around the room, are artists, ask we want to know what is quantum physics. What do you do? What does an average Wednesday look like for you, and what are you doing, and should I be scared?
Okay. All right, so I should start. So my name is Martin. I'm French, so that's the French connection. With Rodolphe. So I've been living in Baltimore for 2 years. I'm a postdoctoral fellow at Johns Hopkins University, so it means I have a PhD in physics and I do my research in a lab. And I'm doing something which is called condensed matter physics. So I'm interested in the properties of matter, the microscopic details which rule the way matter is organized. And specifically what I do is that I create new materials and I create new materials and I try to understand how electrons move in those new materials. And as most of you know, even if you are not quantum physicists, when we look at matter at a very small scale, the rules which apply to the common world do not apply to microscopic electrons. They behave in a way which is very difficult to understand. And there's a theory to describe it, which is called quantum mechanics. And what we try to do is to make sense of this theory, to relate the experiment we do to this theory, and to extract some knowledge I could share with you, for instance. But it's a very difficult task, and people have been working on this field for maybe 100 years, and we still do not understand, when we have 3 atoms together, we still do not understand what's going on. So I'm working with solids, and I actually brought some of this in my pocket today. I don't know where they are. Yes. So this is very tiny. This is the materials I'm studying. These are little crystals.
Can you pass them around?
I can pass them around. So you should. This is actually quite expensive in a sense. This is the work of grad students and postdocs, and this takes, for instance, 1 year to grow. So these are little crystals. You can pass them around, and in these crystals, you have little electrons which move, and what we try to do is to understand those crystals. And you can see the name of each of these materials. So my research is really trying to understand what's going on with these materials and under the light of quantum mechanics.
Thank you. Thank you for being here. Our artist, I thought by way of introducing Rodolphe, we could ask, Rodolphe's been in Baltimore for 10 months, and we could ask, what's your impression of Baltimore, and specifically doing a show in Baltimore, what's it like?
Well, I come from Paris, and Paris art scene is very different from Baltimore art scene, but not in the good way. I mean, Baltimore art scene was such a surprise for me, because I didn't know we could work together and welcome foreigner people like me, and just after 10 months ask him to do a show and to trust this guy who nobody knows, and ask him to do a show. So that's so I love Baltimore, I have to say, and I'm really unhappy to leave. But I guess the connections and the friendships, the new friendships I have here will last for a long time. And so I mean, that says a lot about Baltimore, trusting someone after 10 months, giving him a show. That says a lot about Baltimore. So yeah, very glad to do it.
Well, so what we're going to do is have sort of a walkthrough of the show, and we want to encourage you, if you have questions as we're going, to pipe up and ask a question, to jump in, and we'll have space at the end for questions too, but feel free to ask questions as we go along.
And also feel free to take the titles of the shows, of the works here. So if you don't have
The title card.
Yeah.
And if you haven't realized already, these works are not just an illusion, they are fragile, so just be careful you don't accidentally step into one.
But it's the last day, so...
Maybe we should start there.
At the end, after.
No, not by stepping, but to talking about.
Oh, sure. I think I'm going to step on it at the end, but yeah, you can. So this work is called the poles, like North Pole and South Pole. And it's made of different pain relievers, aspirin, paracetamol, and it's the process is just I take one pill and with sandpaper I do powder with that, and yes, this work is. Reveals a lot of how I'm working. I like to make conjectures and to have with two different ideas and two different concepts, trying to do one work with that. Here, the idea of healing and curing pain. And the idea of the magnetism of poles, and basically I was interested in the way scientists in the 16th and 15th century saw the idea of healing. For example, some doctors at the time thought that it would be possible to cure people at a distance. And at first it was a scam, but I was interested into the idea of when you, with that scam, with that ID, you can talk about real phenomenon, real natural phenomenon such as magnetism of Earth. And yeah, that's basically what it's about.
So
It's you.
okay, so
Your turn now.
So the reason why I'm connected to this is because what I do on these little crystals you guys had the chance to touch, these crystals are actually magnetic. So in those crystals you have poles, exactly like Rodolphe drew on the floor, and you see here that the two poles are close to each other. And in magnetism, it's usually the case that the south pole is close to the north pole, and you cannot take them apart from each other. If you do so, you create a very strong magnetic field, and so if Rodolphe had put these two things further away, there would be a lot of tension in the room. So the room would be filled with a magnetic field. And so in one of the crystals I distributed to you, something extremely important happens. A new discovery was actually discovered here at Johns Hopkins, which is the fact that you can disconnect these two poles. You can take one of them and you can make it travel all the way extremely far away from the south pole. And this is a property of quantum mechanics that you can fractionalize these two poles. And when I saw this piece of art by Rodolphe, I was like, oh, but that's like the poles in my little crystal which is in my pocket, you know. And so during the opening of the show, because a lot of people were walking on the art, it created some tension in the room. And that tension was exactly like the magnetic field between my poles and my magnet. You know, I found it extremely amusing that people were really. So for those who were here, it was really a tense moment, and Rodolphe was, you know. But I found this very well connected to the idea of an idea in physics, which is the idea of a field. So there is something you do not see, but which connects objects. And objects, for instance, in solids, electrons organized following the field. And the way we are organized around the poles right now is actually following this magnetic field. We are not organized in a random way, we are just surrounding it. And that's the way electrons do in this crystal, when you cool it down to very low temperatures. So this resonated very naturally for me. I don't know if it's what Rodolphe wanted to say in this place, probably not, but as a scientist, that's the way I can understand this art. And actually, that would be a very nice way to explain to people what I do. And that's what we discussed before the show, that the pictures Rodolphe succeeded to draw here, they are extremely powerful. They convey a message which I failed to convey with showing you my little crystal. But having the poles like this, Rodolphe is really expressing what magnetism is, and I think it's a great success, and it resonates for me in a very, very particular way.
Did you get all your crystals back?
Yeah, someone stole the magnesium.
It's round.
It's the most expensive.
No, this one I don't care about.
So where do we go next?
I have a question.
Oh,
Yeah.
Could you tell us why you use the two different painkillers and
I guess it was a formal choice, but also I guess the influence, I mean, for me being in America was different in many ways. And for example, self-healing, you know, you go to the CVS or you go to Rite Aid, and you have like a lot of, you have the whole aisle full of various pain relievers with different colors. And I guess for me it was like going to the artist store and choosing different colors, but it was pain relievers. So I guess it was the influence of US on my work, I think, of American, yeah.
Did that influence your shirt choices today?
My what?
Your color choices for your shirts.
Yeah, it's a riot t-shirt, so yeah.
You should explain the duality of two types of things.
Oh, you can explain it, I think.
I'm not sure.
Because,
So you know, in France we have two types of pain relievers. It can be aspirin or paracetamol.
oh yeah, I didn't know that, but yeah.
And someone came to the show, the first show, and said, "Oh, but this is Advil versus ibuprofen." So and the world is split in two: the people who take aspirin and the people who take ibuprofen. Right? And that's the two poles. So you should choose your side in terms of pain relievers.
Well, it's clear here.
But I think it's So I don't know. That's someone came up with that.
Yeah, I didn't know that. Yes. But what's fun is the unconscious political implication of the work. When I tried to do like poetic works, and finally it turns to have political implication and social implication. And I guess we can, because another work that is made with medicine is the other here. We can go there. And yeah, this work is called De Magnete, which is a Latin term. And it's a sleeping pill that I turn into a magnet. So it's not really magnetic, but it's just a metallic plate. But what I just noticed is that the name of your crystals looks like the name of the sleeping pill.
So
you see?
which one is it?
I mean, it's just
There is a formula.
Yeah, so, formula. Yeah.
So to me, this one resonates. So I mean, it's evidence that it looks what I do. You know, I have this little thing, and I want to understand what's inside. And this pill is make people sleep, right? And
yes,
because of its particular formula, which is also written here.
Yeah, and again in this work, it's like I was trying to use the intuition I had between sleeping and magnetism, and I like the idea that when you sleep, you are at total liberty to feel the magnetism that influence you as a body. Yeah, so I found it very ironic, the fact that the sleeping pill already looks like a magnet. So, yeah. That's.
And I think that irony expresses itself in science as well, in the sense that a small object can be the subject of tremendous scientific interest, and a lot of research can be done on one of these crystals I have in my pocket. We've been studying them for 2 years now, and teams of scientists study them, and we still do not understand what's going on in these materials. And it seems to be a very tiny, non-significant object. However, it's very difficult to understand its intimate structure and intimate behavior. And this piece of work somewhat expresses that in a strong way, because this is a tiny object, but you associate a lot of meaning to it and a lot of power, actually. It makes you...
And it has a real power.
It has a real power.
It's funny because in a lot of segments of the art world, there's a prejudice for the really big, make it bigger. Like there's some art faculty, like won't look at a drawing unless it's a certain size kind of thing, or a painting unless it's a certain size. Sculpture has become like these construction projects in a lot of segments of the art.
Almost architectural process.
Right, right. And so, I mean, anyone can feel free to disagree with me, but it's so, this is a very different way of working, and you're saying that, if you're looking at it under a microscope, what we perceive as small might not be small at all.
Precisely. It's infinite in in two directions, The world, the more you get into it, the more complicated and complex it will be. So, we have two infinites in the world, and this is one of them.
Depends on the scale.
Depends.
where
So
you-
the scale you're looking at things that might vary.
and how you choose to look and you choose to stare at things, and it's because sometimes how just by changing your point of view, it also can change the scale of what you're looking at.
Yeah. And so I think it's.
Yeah, I think it's.
But that might connect to the black holes and the
Yeah.
idea of observing them. I don't know.
Yeah, and the idea of something very big and something very small. Yeah.
I don't know if you want to.
I know, yeah, let's do it.
I'm just suggesting.
I know, you're right, you're right.
Very good.
So yes, this video is a coffee reading session. So it's basically someone that can looks into the future or into the past by reading images in coffee ground, and which is more of a Turkish and European tradition. And maybe here it's more like tea leaves reading. When in Europe it's more coffee ground. And the subtitles are the names of all the known black holes in the universe. And it's just the idea that a black hole is like an unknown phenomenon, right?
Yes.
And you can only see black holes by what
They are not.
yeah, exactly, by what they are not, by what it produces around it. And they produce a deformation of light and time around it. And for me it was similar to a single people who can read into the past and into the future of another person. Yes. So again, we have here this idea of showing at the same scale something so big that we can only imagine it, and that which is also similar to the idea of a simple coffee cup where you can read the future, and this is the idea of reading the future is so big that you can only imagine it in a coffee cup. You see?
I see.
You see what?
Okay, so So I really like this one, and so I'm an experimental scientist, so it means I'm doing experiments, and this is very well connected to that idea. The lady here is doing an experiment. She's taking an object and she's observing it, and under what she knows, which is reading the future in the coffee, but it could be anything else, she's doing a prediction. So this is very well connected to the scientific endeavor, which is really taking an object and trying to understand it. So to me, that resonates very well with what I do. And someone asked, what is a typical Wednesday afternoon for a quantum physicist? And actually, this is what it is. You take your sample, you take what you are studying at the moment, and you look at it under very different angles, trying to have something emerging from it. And because you are trained as a scientist, you know how to understand it, but she's trained in a particular way to read the future from it.
Yes, absolutely, because she has a census of images, very particular images, it's like she could see a bird or a snake or stairs, and when she showed me the images that she could read, I couldn't read it because I had to change the scale of my sight. You know, I had to look deeper at a smaller scale. And yeah, so in a way, it's not the question of believing if she can really read the future.
Which she cannot, by the way.
Maybe I agree.
But okay, so also something I like about it is the idea that she tries and fails. You know, she's like, maybe this is like this, maybe not. And this is what we do as scientists. We always fail. Most of the time, as we discussed before, 90% of the time what I do in the lab is screwed up. I fail my experiment. And sometimes it works. And to me, it appears here that she's sort of doing the same. She has difficulties to see what's going on, but suddenly she might realize there is, as you explained to me, sometimes she can see a rat or a snake, obviously. And but so this and the two dimensions you are exposing here, this little thing, this tradition she's having, and the name of the black holes, which are the biggest structures we know in the universe. This paradox between the two length scales is very, very scientific in some sense, because when I study my materials, I just want to know what's really, really inside. And I have this problem having two different scales. My scale and the scale of the phenomenon I want to study. And to me that resonates also extremely well with that idea of two infinites and two different worlds which we like to. I don't know if that makes any sense for anyone, but...
Yeah, that's what we were talking about before. It's the idea of when you, as a scientist, when you make a discovery, you have to name it and you have to give a name to that. And as soon as you do that, you reduce the complexity of the phenomenon.
Yes.
And so, for me, talking of science and natural phenomenon using the tools of art is more a way to give back a certain complexity to the phenomenon, and not using words but using forms. And so, but it's always starts with my incapacity to understand science. It's really what motivates me. You know, that the difference between what I know and what I want to know, and the more I know, the more I know that I don't know anything about science. So it's endless. So that's great.
That's good.
That's good, yeah.
So maybe I can rebound on this idea of the language. So I'm every day exposed to a problem when I want to describe what I do. And we have words to describe particles, like electrons, neutrons, or more quantum objects I'm studying are called spinons, monopoles. This is a name which connects to a lot of physical phenomena. But this name reduces what the phenomenon is. And some people might not agree if you call one phenomenon with this word. And all my work is trying to convince my colleague that I'm using the right word, or word they understand. But most of the time it fails because people have different opinions. And we come down to an idea that there is no truth really, even in science. It's always defined by the language you'd like to use to describe a phenomenon. And your work approaches this difficulty in the language. And it's so radical that it says, I don't need a language. I can just use a picture, a very strong picture to summarize this phenomenon. And that's a form, and that's what the magnet is doing, that's what this is doing. And this is very inspiring to me because it tells me, okay, I should not use complex words, I should not use complex ideas. I should try to have a picture emerging for what I do. Something as strong as this little pill there, which summarizes all what magnetism is. So I don't know if that resonates for other people in this way, but that's why I like this.
Or that the picture can hold multiple interpretations that could be computing as well.
That's right. So you should, yes, that's right. One should be able to find a strong enough picture so that nobody can doubt about it.
or maybe it could encourage communication between these competing.
Yes, yes, precisely.
Do you draw?
I'm very bad at that. I draw on the computer. I draw diagrams trying to explain my research. So it's not drawing in an artistic way, but it's trying to have pictures of the quantum physics so that people can understand it, and in particular my colleagues, but at some level probably all the people. So this is interesting so today I just got an article which is going to be published online in Nature Physics, which is one of the best physics journal, and what we did is we created a lot of pictures of what we see, and that pictures succeeded to convince other scientists that it was worth being published in such a paper. But really, the results themselves are important, but not so important. But what we succeeded to do is give a clear picture of the phenomenon. And because of that, it adds some appeal for other people. So, but this is extremely difficult. It took me years to have these drawings of arrows being correct. But for you, it's simple because you can be radical. You don't have to be. It does not have to be the truth. Art can really be much more powerful than that.
Because it deals with intuition. I mean,
yeah.
for me, not for everyone, but yeah. But we can because
we can walk on the.
No. I was talking about in a way how living in America influenced me, and that makes me think of this work here. Yeah, it works. Don't you smell? No. And so it's a odor sprayer, and I replaced the perfume inside the sprayer by photographic fixer. So if some of you knows the smell of a dark room, you are probably smelling it right now. And I call this work Northern Lights, which is also the name we give to Aurora Borealis, and so it's a natural phenomenon, paradoxically a very visual phenomenon. It's green light in the sky, in a dark sky, and it's even if only a few people saw that phenomenon, we all have an idea of how it should look. And so paradoxically, instead of showing something and talking about vision, I choose to replace the sense of vision by another sense, the olfactive sense. So there's this game of replacement going on. And well, yeah, I was talking about American influence. Before we came here, we were told that you'll see in Baltimore, and the light is very different. It's very. So I'm not very sensitive to light difference, but what I liked in this idea is that people told me that they perceived light differently, and even if I don't feel it, I felt like I needed to talk about it. So that's, in a way, the influence. But maybe it's not related to your...
So this one is more difficult for me to connect with what I do, obviously, because it's more technological object, which you are using. You use it in another way than it's supposed to be used. So for me, that's more difficult to connect to what I do, because I'm not trying to do any object which will be used in this real world. I'm just trying to do fundamental things. However, the chemical thing is connected to science. The product which you implemented in this machine is a product of an industry which refines this product in a very clear way and to be able to reveal photography. So it's, yeah, I don't have much to comment on this one, but I like it too, and I wish it sprays at some point.
I like the idea of how something industrial production, making chemistry, is used to do individual creation, like black and white photography, and yeah, maybe.
Yeah, so that's connected to the DIY aspect.
Yes. Maybe how DIY uses industry skills.
Yeah.
You see?
I see.
So at some point it'll spray.
Yes.
Yeah. Every 5 minutes. Yeah.
And you can hear it?
Yes.
You can hear and see and
we all
smell.
You can wait. But no.
But you can see that the floor was eroded by the
That's what I was wondering.
projections.
Yeah.
Yes, that's. I was surprised to see that at the end the floor, something visual came from it. It's. I didn't think it could happen because this is not very visual. And yeah, and
The lights, the speed of lights.
yes, which is more of your domain.
Yeah,
I think.
this is this one.
Yeah, this work here, and the other one here are a couple of candles, only lit for 8 minutes and 19 seconds, which is the time for the sunlight to travel from the sun to the earth. So what I liked is, what I wanted to do is representing the act of vision, but with the disparition of the matter, because in order to produce light, the candles need to disappear, and that's this paradox I really like in that everyday object. Everyday, yeah. Yes, that's it. Yeah.
So maybe I can talk about, we discussed about this quantum physics versus gravity. So
I'm not sure to understand that properly.
okay, so that I try to explain to Rodolphe, so you have to tell me if you understand. So what Rodolphe used here is the fact that the speed of light is limited. So the light takes 8 minutes and 19 seconds to come from the sun to Baltimore, and use that physical constant to produce these numbers. And this is connected to the world of gravitation, which rules the interaction between the planets, the black holes, all the massive structures of the universe. And in the same room, we also have these magnets. And the magnets use a very different force in physics, which is called electromagnetism. And actually, in quantum physics. And actually, the physics of gravitation and the physics of magnetism use very different languages. And this is one of the greatest deal in physics right now, trying to have a common language to describe these two phenomena. The phenomenon of microscopic interaction in solids and the phenomenon of gravitation at the scale of the universe. And these two theories are not united up to now. And Rodolphe simply put them together in the same room, expressing that, hey, physicist, I can do it, and you cannot do it. But you've been able to describe it in the same language. But this is something we cannot do. And this is, I don't know, I just find it funny that you can be so radical in that.
And what's interesting is that, of course, I really didn't know what you're talking about before.
Yeah.
And what's interesting is that the role of intuition seems to be central in artist work and scientific work.
Yeah, so without knowing it, you use the rule of physics and you use a physical phenomenon to construct your work. And of course, you are in a world which is ruled by physics, so you have no other choice than to use these rules, actually. That's right. But sorry about that. It's all physics in the end. We always win.
But you always produce images, so...
Yes, that's right. That's right. But I found this paradox very interesting. Pictorial. So, I don't know if you guys were aware of this fundamental problem we have, uniting these two theories, Einstein theory. Actually, Einstein produced the two theories, but it was
How could we live before knowing that?
Oh yeah, how could you? But
At this point, does anyone have any questions?
I knew about the candle groupings. Seeing as these are all different colors, and the other two are just black and white.
Yes.
Is there?
Again, it's a formal decision, but these are close to primary colors and to the decomposition of light. And when you take white light and you decompose it, white light is made of different colors. And I guess this is why I wanted to use different colors. And also, I guess this is why I choose to do another one in black and white to remind the idea of photography, and black and white photography and color photography or images in general.
I just had an idea of so actually, we know how far galaxies are. It's because the light they send has something called the redshift. So the color of the star, which you see in the telescope, shifts as it travels in time, and it gets more red. So if a galaxy is very red, then you know it's at a given distance. So actually here, you use that phenomenon in some sense. Your light travels from the sun and separated in different colors. And I think it can be reconciliated with that. You didn't know about that, but
I knew.
Again, the principles of physics guided you to do it without you knowing. Anyway, that's not the message I want to send.
There is an invisible hand.
Yes. No, you can always choose what you want to do.
I'm not sure right now. Yeah, we can talk about this work now.
Yes.
And I don't know if you guys knew this painting. It's at the BMA actually, and it's a French painting from the 18th century by Chardin, and it's called the Knuckle Player. And on the original picture, what you can see is a young girl who chose to play knucklebone instead of sewing, instead of working. I just uses images and just put it upside down. So the ball she's throwing in the air just follows the gravity. And I guess what I was thinking when I did that is the idea of a revolution, but I mean the revolution in terms of when you put something upside down, like for example the Copernican revolution, which was a physical discovery that changed philosophy and knowledge after. So I guess it was a kind of an homage to that, or something like that. But maybe it's not your domain again.
Yeah,
maybe you don't have.
I can interact like anyone on this one. I mean, No, but
Easy.
well, I was at the BMA yesterday and I saw it. I like it.
Ah, you saw it?
I went there to
Okay.
see it.
So I don't
yesterday,
know.
but-
Yeah, you can see it in real. It's a beautiful painting. Also, I like the idea of instead of working, this girl chose to play, and by playing, the game reveals more about the universe than the work itself. So, and I think it's right. I like this idea.
Very French idea.
I mean, was it, did you know this painting before, or it was being here and
I discovered
cruising
it.
through the BMA that...
I really discovered it here, yes. And it was interesting to discover a French painting in Baltimore, a painting that I didn't know before. Yeah, and now, thanks to the BMA, Chardin is one of my favorite painters. Yeah. I don't know if you want to say something about
Not necessarily.
it. No.
If people want to.
You don't like it?
I like it. No, it's not.
Yeah. And I guess the last piece I have here, it's this one. It's called seismometer. It's just basically two empty glasses that waits for an earthquake and to vibrate. And if some people here were at the opening, maybe you noticed that I didn't show it the same way. It was on a little shelf, and the day after the opening, I was watching a movie called The Sacrifice by Tarkovsky, the Russian director, and there is one scene where you can see a maid staring at a glass, and while the sound, the tinkling of several glasses, you can hear the sound coming with the earthquake, and these glasses were on a silver plate like that. And when I saw that, I was like, well, this is my work. This is what I wanted to say, actually. So I decided to change the presentation of the work. And yeah, yes, that's it.
So what Rodolphe explores here is the idea of waves, and this idea is very important in quantum physics because, as you probably most of you have heard, there is something called a particle-wave duality. So in quantum physics, we can describe objects as particles. An electron is a particle, it's a physical ball of matter, but it's also a wave traveling in empty space, for instance. And we can choose in physics to describe phenomenon using particles or with waves. It's equivalent. The result will be the same. It's just a different point of view, a different language. And this seismograph is actually trying to measure all the waves in the room, and that's precisely what I do in my experiments. I measure the waves traveling in solids, and you're trying to capture the earthquake created by the light rail or you know, the vibrations in the room. And,
of the street, of the people walking. Yes.
Yes. And however, those waves are really, really tiny, so they are imperceptible. But still, those glasses are shaking at the moment, and they are resonating with the waves and the light rail.
And yes.
And they're liquid too, right?
And yeah.
Glass.
Yeah, well, and on top of that, but what's funny about it is that in a glass, actually, matter is not organized. A glass is a state of matter where the atoms are randomly placed. And waves have actually big problems to travel in glass because it's not organized. So you cannot create a collective motion of the atom. So I think there is a paradox which is beautiful in the fact that the object you use is actually not transmitting waves so well. However, because you put two of them together, you create the ability to measure those waves by contacting the two. So again, you use physics without knowing it. But, or knowing it, but you know, in your intuition. And,
Yes.
and so that's what I can say about this one.
And now I think
Maybe we should.
oh yeah, take fresh air
Yeah.
because there is a last work outside on the front of the gallery.
Yeah, that's a great. You should have a show, a radio show. I think.
Okay, vas-y.
So, oh no, oh it's raining.
It's raining?
Yeah, a little bit, yes.
I don't feel it.
Just
I got a hat.
So this work holds the name of the show, of the attraction of the sun, and it's just actually a sundial made of made with a blind cane, a walking cane, and again I was interested in the idea of attraction of the sun could be read in both ways. The physical attraction and the visual attraction that leads you to blindness, and also what I like is the also Baltimore influence. The front is full of holes, and it's like a history of this building. And what I like is I decided not to show the hours, but because of all these holes, they are already here to show the time. Yeah.
So okay, I can say something about that. So actually, why we started discussing is because of this. Because you had this idea, and Rodolphe asked me, I have this idea, you need to help me calculating the angle. I should put the stick so that it can really give the actual time.
Yeah.
And so then I browsed the web trying to understand, or to calculate the angle you have to, and it's actually very complicated to calculate. And I have to say I gave up. And I didn't tell you that I was not able to do it. But that's actually what it is. But yeah, but that's just. But that's how we started to collaborate, because not to collaborate, but to discuss about science, because you needed to calculate the angle, which is something I was not unfortunately able to do. But
and finally, you gave up, and I decided not to use the right angle, because there's no need for angles if you don't have numbers. So that's a random decision that leads to formal decisions.
That's interesting. Welcoming the failures again.
Yes.
At the very beginning, at the very entrance.
Yes,
precisely.
yes, that's right.
So the failure generates the result, essentially.
Yes, and forms. Yeah.
Do you have, when you've been here, and I know some people are here a lot at this space, do you think, have you noticed people noticing it, or have you gotten any questions about? I mean, it's a mural, right? It's like it's a public art.
I guess mostly, I think when people were looking at the map, they were trying to find, like, there's one more. Yeah, where is this?
I told you there's one more.
But it's like the black hole.
Yeah.
It's right above your periphery, so it's probably,
It's higher than you might look.
What's funny also, it reflects in the wall, so it gives another indication, which is one time.
Yes. So when it's not, because now it's not working because there's no shadow, because I mean there's no light, no sun. But as you said, you can see the reflection in the glass of the. Yeah.
What is that? Linoleum?
No, it's
Like a big bolt?
magnetism.
It's a secret of the artist.
It's drilled in the wall.
Is there like a big bolt through it? Or?
Yeah, it's like there's the road inside.
It's hard to figure out how to stick things to things.
Yeah.
Should we go in out of the sort of range? Go back in?
But we can
Yeah,
conclude
if there are
maybe.
more questions. Yeah? About the poem? Yeah.
Merci.
I'm laid off.
Le frère Bogdan.
Un peu mieux quand même.
Yeah, I wonder if you could say something about your future possibilities of collaborating with scientists.
Actually, there is in France. I'm applying for a PhD, a new practice-based PhD for artists that wants to work with scientists. So it's something very new for me, but yeah, I guess that's the way I try to work. I try to work with scientists in the future. I hope. But I mean, collaborating with scientists is something new, because I was just reading science before that. I wasn't collaborating. It's actually the first collaboration. Yeah.
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 The French connection helped, I suppose, but
Sure.
and that's the first time I tried to discuss my science with an artist too. So it's, and I think I want to do it more. And if I come back to France, then we should collaborate more.
Yeah, but there's also a lot of artists in
Yeah.
Baltimore.
Yes. And so I think what I really liked is when you came to visit the lab and
Oh yeah.
and I don't know, I think you were surprised by the way it looks, right? Or not really. But
there's nothing more similar to a lab than a lab, I think.
yeah.
It's
Not my lab.
no, I mean, I was surprised by the fact that I wasn't surprised, because you said that your lab is not something huge, and there's nothing very attractive, and
Yeah.
no, it's
But I have to say I had a lot of fun doing it. I mean, when you came to the lab and I had to explain what I'm doing, that was a lot of fun, and I wish we could encourage that to happen more. And just people to visit, and it helps to, science is not as simple as art. It's just a natural thing people do, and should not be considered as something beyond the understanding of people. You can really come and enjoy and understand what we do, even if it's at the forefront of research. And I think as scientists we are sort of failing in doing that. We should be able to convey more what we do to the general and the artistic public, and I think that created that idea in my mind. Yeah.
But what's difficult is, I think, scientists, they have their work to do, and it's another job to talk to people about science, and to.
That's right.
So that's scientific writers is a work in itself.
Yes, that's right.
Scientific writing. So I really understand when scientists cannot. I really understand why they cannot explain their work.
Well, after many natty bows, that was actually very easy to share. But
I think there's another.
This poem, was this one that you had known a long time, or was the poem new to you?
No, it was new to me. I discovered it at the Hopkins Library. I discovered that poet here. Again, another influence, direct influence of Baltimore.
So it was on display at the library, or?
No. I was looking for books, but I found it almost randomly. Yeah. And I can't say I liked it at the beginning because it's an old English, and I couldn't really understand it. But again, it was what I liked in this poem is that it was natural to understand it.
And Cavendish is one of the greatest solid-state physics lab at the University of Cambridge. It's called the Cavendish lab, and that's the name of the. Actually, that's his sister. Or?
The wife.
The wife of the physicist at Cambridge. So again, it's very well connected to everything. It's astonishing. The intuition drives that so accurately.
And is she known herself as a scientist, or more like a science enthusiast?
No, she was a philosopher and a scientist, but she knows herself as a scientist. Yeah.
Probably more successful than the husband, but
yeah.
those times the honor came to the husband.
Yes, I think now we're more talking about her than his husband. Yeah.
Well, we should probably wrap up unless there's one more burning question.
You can always chat with us.
But thank you very much.
Yes,
everyone for coming.
Thank you.
All right.